Hello everybody. I welcome all of you to third lecture on SageMath. I hope all of you did the assignment of the last lecture. The solution of that assignment I will post in this weekend, and I will also give you the assignment of the current today's session. So today I'm going to look at some brief programming essentials that is required to use SageMath. In case you don't want to use SageMath just as a black box, in that case you need certain programming skills. So as I said, SageMath is based on Python programming language. So whatever I'm going to do basically is a Python programming language. So in case you are already comfortable with Python programming language, it will be just a repetition. However, let us see how we can make use of some of the Sage commands or Sage features in Python programming language to make the program even much simpler. Okay, so first let us start with some simple commands where using that we can generate sequence of numbers in certain order or certain satisfying certain properties. So one of the command which you will, if you are using Python, then you will keep using this command is called range function. Range. If I say, for example, range 10, then it gives you a number. It generates a number from 0 to 9. So I'll need to list this number. So I'll say list range 10. Sorry, list range 10. Then you can see it creates a list 0 to 9. So it starts from 0 and generates 10 numbers consecutively. Therefore, it will stop at 9. If I want to go up to 10, then I need to say 11. If you want to generate this number, let us say if I say list and say range 1 to, for example, let us say 20, and with step length, let us say I will say step length 4. So first number will be 1, second number will be 1 plus 4, that is 5, next number will be 5 plus 4, 9, and so on. So let us see what it generates. Yes, so 1, 5, 9, 13, and 17, right? The next number will be 21, so that is not less than 20, so it will stop at 17. Okay, so this is how you can generate. So this is basically an arithmetic progression with the common difference 4, right? So in case you want to generate, let us say if you have a common difference which is, let us say, a fraction, then this range will not work. Suppose let me try range again 1 to 20, or let us say 1 to 10, and with common difference half, then this will give you an error. So this range works only for integer difference. So in that case you have to use what is called S range. So S range this, and then let me ask it to list again. So list, this will work. So first number is 1, then next number is you add half to 1, that is 3 by 2, and so on. So keep on adding half. It will just go up to before the 10, right? So this is, if you want to have a fraction difference, instead of half, suppose if I say point 2 instead of half, let me say 0.2, then again this doesn't work. So you have to, in this case, you need to, sorry, one, right, yeah, it works. So you have to say that uh, that this S range will work even for the fraction decimal increment, right? Another two important thing, let me just I'll just comment this out, or let me just, okay, so this command, okay. uh, Another thing that you should just maybe try to learn is another important function. See, in as I said in the first lecture, this this Sage worksheet, you can use it to write all your Python program. So for example, in Python, there is a library called NumPy. So if I want to import NumPy, I can simply import from here. So import NumPy as, let us say, short name NP. And inside NumPy, there are functions to generate this kind of sequences. So if I say, for example, one function that I can say NP dot, so inside NP, now let us access a function called a range, and in this case let us say 1 to 5, and common difference is 0.2 again. So this will also work. However, this generates as an array, uh, but S range generates as a list. So that's the only small difference. Similarly, many of you might be using MATLAB. There you have a function called np dot linspace, and in that case, let us say if I say 1 to 5, and I can ask, let us say, generate say 20 points between this, then you will get 20 points starting. So it will divide this whole interval into 19 parts. So if I say, for example, 21, then we will see that it is 1.2 and so on, right? So these are another two important function to generate sequence of numbers, because in case you want to kind of plot graphs, etc., you need to generate these points. Okay, so this we will keep using as we go along, right? Next, let us look at how to define user defined function, how to define functions. So we if you recall, we already defined, suppose I want to define a function f of x, we already defined function of 1 and 2 variables in last lecture. So suppose if I want to say fx is equal to x into let us say exponential of minus x, let us say minus x square by 2, this function. Okay, so this is perfectly all right, it works here. But in case you want to define the same thing in Python, this is not how you can define. So there one has to use a function called def, a keyword def stands for definition, and then give the name of the function f, right? And then you write the arguments and then put semicolon. This is important, put semicolon. Semicolon means there are something more to it, I mean there are some more commands that will follow, and then press enter. Now when you press enter, you can see here automatically the cursor shifts little bit to the right, few characters to the right. That is what it will do. That is indentation, and that is very important in Python. Okay, so now let us write. So we wanted this function, right? So what we can do, we'll simply say return what? This x into e to the power x square by 2, right? This is, so these in Sage, these two things are essentially the same. However, in Python it will be slightly different. So this is of course very simple function. In case we have more complicated, where the function depends upon various conditions and other things, etc., in that case you need to define it like this. We will come to several examples, right? Now suppose you have, let us say, some list, let us say L. Now I can ask for what is the value of the function at, let us say, minus 0.5. Will tell you what this is the value. Suppose you have a list. Let us generate some random list. So how do I generate a list? I'll call that a list as L, and this is equal to, let us say, some number, let us say 0 point, or let us say start with 0 followed by 1, 1.5, minus 2.8, 7, let us say 8.5. That's it. Let us say this is a list. Now suppose I want to apply f to every member of this L. So suppose if I say f of L, this gives an error, so it will not do. So of course there are ways in which one can do, but you can also use a keyword called map. So you can say map f to each and every member of L. Okay, now this is fine. Now I can call this as make a list of this. So you can see here this has evaluated the function value. Of course, some places it is not putting in decimal, so I need to put a decimal there, then you will get it. Okay, so this is uh, how you can make use of map. This is very useful function whenever you want to apply some function to every member of certain list or tuple. This is very useful. Okay, so right now let us say, for example, I had given one exercise in the first assignment, that generate a random number, random 10 digits number ending with 1, right? I think, and then several of you asked me actually, how do I do that? So that time I said it, you can at present you can just give manually, but suppose you want to write a function for that. Suppose you want to write a function for that. So there is a function called rand int stands for random integer. So rand int, if I say for example 1 to 100, 1 to 100, then it will give me a random integer between 1 and 100. Now suppose I want to generate what, 10 digit number, right? So how do I get 10 digit number? So if I want to get a 10 digit number, then I can say rand int, let us say 10 to the power let us say uh, 9, and 10 to the power, let us say for example if I say 10, let us say 10 to the power 2, and 10 to the power let us say 3, 10 to the power 3, right? Then you can see it generates a 3 digit number. So if I want a 10 digit number, I have to say 10 to the power 9 and 10 to the power 10, right? But then last digit may not be 1. So for example, I say 10 to the power 9 and 10 to the power 10, then I don't have last digit 1. It is a 10 digit number, but I don't have last digit as 1, but I want last digit 1. Of course one can do various things. So instead of so what we can do is, one approach is, I will generate 9 digit number, and then multiply that by 10 and add 1. So when you multiply by that 10, it will become 10 digit number and add 1 to that, right? So let us see what you can do. So what I'm doing, I'll so that generate only 9 digit number. That means I have to say 8 here and 9 here, and then multiply this by 10. So 10 into, and then plus add 1. So now you get, this is a 10 digit number. So you can make this a function. Let us say we want to make this as a user defined function. So let us say I'll call this as def. Let us give some name to this function. I will call n digits and then underscore, let us say ending underscore with, I'm giving a big name, but it's all right, ending with, let us say whatever. So I'll give two arguments. One is number of digits, that is k, and ending with in this case let me say ending with r, and r should lie between 0 and 9. Then colon, again press enter. Remember, when you press enter, this your cursor will go uh, uh, at one tab inside. So now we have to say what it should do. So I will say that, let us say generate a is equal to a random integer from of how many digits, k minus 1 digit. So I need to write here, k minus 2 to k minus 1. So this will be k minus 1 digits, and then I'll say return. What should it return? It should return, multiply this number a by 10 and add 1, right? Now let us see n digits ending with, let us say I want a 10 digit number ending with, if I say now 3, ending with 3. Sorry, I have to say here r, right? Because I said 1, so it will be last digit as 1. So now wait for just a second. Right, so now it ends with 3, right? So whatever the end digit you want, the units place you want, you can say. So this is one way of generating a random number, as many digits as you want, ending with a particular number. Okay, so this is uh, quite useful especially when you want to do this many times, then it is quite useful. Another thing I had asked in the last lecture, I had asked you to generate a graph of a curve along with its curvature, and the curve was given as figure 8. So I think several of you have already done this assignment, and but this is quite easy. So this is the curvature function. This is a curvature function. So let us see, I want to make a user defined function for this. How do I do that? This is quite simple. So I need to define a function. Let us say I'll call this as def. I'll call this as curvature. And what are the input it should take? It should take input, let us say f of x, and let me say g of x. So these are the two things, or you can say only f or g, f and g. Let us just say f and g, f comma g, right? And sorry, we should not press shift enter, just enter. Now write the body of this function, body of this function. So let us see. This is quite simple. So I'll define numerator. I'll define numerator and denominator. So numerator is differentiate f with respect to x, multiply this by the second derivative of g with respect to x, and minus minus derivative of g times second derivative of f, and denominator is derivative of f whole square plus derivative of g whole square to the power 3 by 2, and then return numerator by denominator, right? So now you can see that if I ask for let us say my f, you remember what was f? F was f of x was sine of x, and g of x was I think sine 2x, 2 star x. And now let us ask for what is curvature of this, curvature of f comma g. So this is a curvature. If I want to find out, if I want to plot this graph of this function, you can quite easily do so. So plot, let us say curvature. So let me just copy this curvature of this, let us say between 0 to 2 pi, 2 star 5. Yeah, so that's the graph of curvature of, let me make it figure size small, fig size let us say 4. Yeah, so this is what this was the problem. And so you can see here, in case we have a user defined function, I can you can make this, or you can use this several times. There is another way of uh, defining a function, especially when you have a very simple definition, and especially if it is coming inside a function itself. Then there is another way. It is called inline function, and one can use what is called uh, lambda keyword. So how do I do that? Suppose I simply want to define function of two variables x and y, and this is simply there, it adds. So I can simply say add equal to lambda, 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 and then give the arguments, no comma etc. Let us say arguments are x comma y, and then colon, and then you give the definition. So what is the definition? It should simply add. So let us say x plus y. That's it. So this is a very simple way of defining. And let me press there. And now if I say add, let us say 10 comma 52 will return 64. If I have three variables, let us say let me call this as I'll call it L, or let us say norm, norm, and this is, let us say norm in R3. So x y z, I'll say what should return, sqrt, x square plus y square plus z square. So this is norm of. Now if I say norm of let us say a vector which is given by 2 comma minus 3 comma 4, you get square root 9. That's the norm. So this is another simple way of defining a function, and this is we call inline function because you can define just in one line. I also you can try to look at help on, there is already inbuilt function to define piecewise functions. So try to explore this and try to plot graph of some of the piecewise defined functions, etc. I will not go into details. Several examples you will see in the help manual, and we know that piecewise defined function come in mathematics quite often. Okay, so right, now let us move to, so this we know how to define user defined function using def or using lambda. Now let us see, when we are defining a function, many times this the return value or the output may depend upon many conditions, right? So you have to do a lot of computations inside. So one of the computation that generally we keep using is called conditional, that is if else. You want to check if else condition. So general syntax, a generic syntax of if else in Python is this way: if, so if there will be some condition, you can write in bracket or need not put bracket. It can be one condition, it can be more than one conditions. So these several conditions can be combined through by and or etc. Right. So and then put colon and then followed by, let us say this is the first expression you want to do, this is the second expression you want to do, third expression you want to do, things like that. And maybe in case these conditions are not satisfied, then you want to do else. So again else and colon, and then again this is the first statement, this is the second statement, and so on. If inside else you may have another if, so you can have, let us say if, so this will go like this: if some condition is satisfied, then again do something, etc. Right? If some conditions are satisfied, then colon, and so on. Right? So you can use if, and it could be nested if else, but sometimes if, else and if can be combined together and to make it elif. Okay, so you can use elif function in case you want to combine else and if together. Okay, so let us take some examples so that it will become clear. So the example, let us say, for example, if I say I have a is equal to something, let us say a is equal to 2.92, and so there is a condition: if a is, let us say, bigger than equal to 0, then do something. Let us say I'll say print, let us say good, right? Otherwise, so else, what do you want to print? Print not so good, not so good, right? So in this case, what will it will since this is positive, it will print good, and if I put here minus, it will now execute the else condition, it will print not so good. Okay, so let us say if I wanted to do, in case a is bigger than 1, then let us say print excellent, between 0 and 1 put print good, and if it is negative, let us say bad. So how do I do that? I can say if a is bigger than equal to 1, then print, let us say, excellent. Else, so I'll have another if else, if a is bigger than equal to 0, bigger than equal to 0, you have to write, then let us say I will say print good, and else, that means where will it go otherwise? So it will go here. Okay, so in this case else will come here itself. Else what do you want to print? Print, let us say, bad. So you can see here this indentation is very important. Okay, so one of the common mistake that many programmer, especially in the beginning, they will do is that they will not put this semicolon, right, and they will put this print in the beginning, so there won't be any indentation. So these are some common mistakes, so try to keep this in mind. Now let us run this. So you can see here this was negative, so it has printed bad. If I say a is, let me put a here now, a is, let us say, 67, then it is excellent, right? But you could have combined else and if, this else and if together to make it elif, right? Elif, of course, then this else will be here, right? Okay, so this is how you can make use of if, else and elif, right? Let us see, this is a very simple example. One of the thing where you must have come across using if and else in mathematics is, let us say, finding roots of a quadratic. So suppose I have a quadratic ax square plus bx plus c, and you want to find its roots, then the roots depends upon the discriminant, which is b square minus 4ac. In case discriminant is non-negative, then the roots are real, and if the discriminant is negative, the roots are imaginary. So you need to check condition on discriminant, and based on that, the nature of the roots, uh, either it is positive, either it is real or complex. So let us write a simple program for that. So first let us say I have a, b, c. Let us say I want a is equal to 2, b is equal to, let us say 5, and c is equal to minus. At 2x square plus 5x minus 2, right? We want to find roots of these. So first we will say discriminant. So let us say discriminant, D-I-S-C, discriminant, or you can say D. This is what? B square. So I can write B square like this, minus 4 star A star C. Let me just, instead of B square like this, let me put double star, so that it will also work in Python, pure Python, right? So this is, we have found the discriminant. In this case, what is discriminant? B square, that is 25 minus 4 AC. This is positive, so roots will be real, and we know what are the roots. Roots are minus b plus minus square root b square minus 4 AC upon 2a. So that is what we want to do. So let us say, now we will say if discriminant is greater than equal to 0, equal to 0, then, or okay, fine, then let us say first print will say roots are real, right? And in this case we know what are the roots. So the first root is, let us say, I'll call this as x1. What is it? Minus b minus b plus minus, right? So let me put plus first, plus square root of discriminant, that is b square minus 4ac, the whole thing divided by 2a, and you have to put star here. And also many people just put it like this. This would mean that you are multiplying this whole thing by a. So therefore the correct thing is you have to put bracket in the denominator. Okay, similarly, what is x2? So x2 is nothing but minus b minus, so this is minus, and let us also print the roots. I'll say print, let me say x1 is equal to, what is x1? X1 is x1. Then other thing will say x2 is equal to, and then comma x2. This is how you can combine text and variables together in print. Else, so else, where it will come? Else should come here. Else, I'll simply say the print roots are imaginary. imaginary. So I have to put this in double quote or single quote. Now let us run. So there is seem to be some problem. X1 is equal to x1, x2 is equal to oh, DSC. I made a mistake here. D discriminant. Okay, that's yeah. So this is these are the real roots. In case, for example, I let me put here instead of -2, I'll put 7. Now let us see what the roots are imaginary, right? Of course, you can also put return. Now suppose we want to make user-defined function of this. So if I want to make a user-defined function, what you have said def, and let us call this function name as, let us say, quadratic, and we have to put input as ABC, and then all I need to do is then press enter and just copy paste this here and put it inside. So I'll just copy paste this and select everything and press tab, so it will just go there, right? So this, whatever the computations I have done here, I have just pasted in the body of the program. And you can see here, first of all, you just check this is the alignment inside the body, right? Everything is aligned in this. And whenever you have a colon, after colon, whatever statement comes, that will go again inside one tab inside. Okay, so that is a basic philosophy in Python programming. This indentation is very important. And in other programming language, for example C, they will put curly braces to combine a group of statements together, right? Here there is no curly bracket notion, because curly bracket is used for dictionary. Okay, fine. So this is, now let us uh, look at what are the roots. So quadratic, not executed, quadratic, and then let us say a comma b comma c. The roots are imaginary. If I ask, instead of this, I can say 1 comma 2 comma 1, right? Let me put here -1. Wait, there is something wrong. Oh, this discrement is not computed here. Okay, so that's a mistake. I'm sorry. Yeah, this discrement has to be computed inside, no? Yeah, now let us then. Yeah, correct. Okay, so this is how you can create user-defined function. So this is another thing you should learn whenever you want to create user-defined function, especially in the beginning when you are learning programming language. First, try to do things step by step. Once everything works, then you put it inside DEF, because it is much simpler to get rid of your error when you do these things without outside this definition. Okay, so now let us look at how we can do things again and again, how we can do things repeatedly. So there is a notion of for loop. So general syntax for loop is going to be something like this. So for k, let us say k is a variable in some set. So if I say s is a set, then again, and s could be anything. It could be a list, it could be a dictionary, it could be a tuple, right? Uh, it could be even a set. The Sage also has several functions to deal with sets. Okay, so this, and then followed by you write whatever statement that you want to execute, right, for each. Right. So let us look at take a simple example. Suppose you want to, let us say, add numbers from 1 to 50. Want to add numbers from 1 to 50. Before that, let me just say for k in range, let us say 5. So the range 5, what will it generate? It will generate a list 0, 1, 2, 3, 4, right? list of 5 numbers starting from 0, 5 integers, and then I'll simply say print k square. So what is it going to print? It will print 0 square, then 1 square, 2 square, up to 4 square, and you can see here. And by default, after every print, the cursor will go to the next line. Okay, that also you should keep in mind, right? So this is, again, notice that there is a colon. It ends with colon here after this first line of for loop, and then you have all these. If I have one more print statement, let us say I'll print something. I'll just say next, right? So you can see first it is 0 square, then next 0, then 1 square, next 2 square, next, and so on, right? So, and these two print statements are aligned, right? Okay, so let us see. Suppose you want to, as I said, you want to add first n natural numbers, right? So what should be, we can use this for loop. So let us say for k in range, natural number starts from 1, so I will say 1 2, let us say capital N, and this capital N, let me define, let us say it goes to 50. I want to add first 50 natural numbers. So but then this range will take 1 to, when I say range 1 to 50, it will generate 1 2 3 up to 49. It will not go up to 50. So I need to say n plus 1, and then colon, and let us say I want to say s is equal to s plus the variable k, right? In s you keep on adding k, but then I need to, for example, if I say k equal to 1, then it will ask for what is s plus k, and it doesn't know what is s. So you need to initialize this s. So I need to initialize this s 0. Okay, this, right? It has computed s. Now let me ask what is, I'll say print print s. Then you have the sum of first 50 natural numbers. Sum is 1275. You have learned a formula from your school days. Sum 1 plus 2 plus dot 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 up to n is n into n plus 1 by 2. So you can see that 50 into 51 divided by 2 is will be 1275, right? So for example, if I say 50, this is quite easy. 50 into 51 divided by 2, that is 1275. Okay, and if I wanted to make user defined function with this, how will I do? I'll simply put def, and let us say I'll say sum of first n natural, again first natural anything, let us say capital N here. This is the definition, and now I don't need require this, and I don't even require print, because we will return, so that we can make use of. So put this inside. It will start with s equal to 0 for k in 1 to n plus 1, s equal to this, and at the end you want to return. So we'll say return, what should return? Return s. Okay, now let us call this function. So this of, let us say 50, answer is. So once you have done this computation, putting it into the user defined function is very easy. So let us say if I, instead of 50, let us say I say some number, so it will take little time, and then it comes. Okay, so this is, let us look at one more example of for loop, and then we will also look at some other thing that you can make inside, use inside for loop. So let us say you I'm sure most of you must have learned Newton-Raphson method, okay, of finding root of a function fx equal to 0, or 0 of a function fx. And what is the iteration scheme for Newton-Raphson method? Xn plus 1 is equal to xn minus f at xn divided by f dash at xn. Of course, you require function to have first derivative. Of course, you in case of convergence, etc., you also require continuous second derivative. But suppose I have first derivative, then we can make use of this iteration scheme. and you have to start with, let us say if I start with n equal to 0, x0, it has to be initialized. So for example, let us say we want to write this function. So what let us say we want to find root of a function called x cube minus 3x plus 1. Let us plot graph of this function. So graph of this function is this. So you can see here there are three roots. All three roots are real in this case. One is between -2 and -1. Other one is between 0 and 1, and there is one root between 1 and 2. So suppose we want to find one of the root or all the roots. How do we make use of this Newton-Raphson function, Newton-Raphson method, and we want to make use of, let us say, for loop. Okay, so let us say we want to start with some initial value. So let us say x0, let us say start with how about starting with 2.5, and then what should be x1 should be x0 minus f at x is equal to x0 divided by derivative. So that is f dot diff, finds derivative with respect to x by default, and substitute x equal to x0. So that is your first iterate. Right, now let us print what is x1. So what is x1? X1 is 1.920063. Now if I want to run once more, then I need to say x2, right? I can say, let us say I can say x2 is equal to, now everywhere I will say x1, this is x1, this is x1 here, and then print x2. So after second iterate you have got this. So it is coming quite close to this first positive first root between 1 and 2. So if I want to do this, let us say 40 times, I cannot keep on writing x1, x2, x3, x40. So we will make use of for loop. So let me just copy this here, right? So this and for loop. So we'll say for, let us say I in range 40. Range 40 will give me 40 integers starting from 0 up to 39. And what you compute x1 is equal to x0 divided by this. Okay, and then but then in the next iterate I need to let me say print x1. So let me not go to 40, let me just go up to 10. Okay, and then you need to, so it will do x1 and then print whatever the value, and then it has to, I will become 2. So when I becomes 2, it again x1 is equal to x0, but then you don't want this x0 has become now x1. So I'll say x0 is equal to x1. Now let us run this. So you can see here 10 iterates, the root has become this. You can find out what should be f dot find root. We know find root between 1 and 2. The actual root is 1.532088. So after 10 iterates, you can see here the root is almost exact. There's so many decimal places. So this is a nice function, and it may not, of course, instead of 2.5, if we start from, let us say 105, then the root will be still quite far away, and it may not converge. That can also happen, right? So yeah, right. So now suppose you want to make this again as a user defined function. It's quite simple. So let me just copy paste this. How do I make this a user defined function? So let us say I'll call this as, the function name is Newton-Raphson. It should take value the function and the initial guess x0, and then but the derivative has to be defined inside. So then yeah, for this now I will not say x 1, I'll say that compute this x1 and then store inside x1 itself, x0 itself, and then at the end, once you finish this computation, then say return x0. Take a colon is missing, right? Now if I ask say for Newton-Raphson method, and what was the function f, we already know f was x cube minus 3x plus 1, and starting s value is, let us say, x0. And how many times you want to run, that you can decide inside the loop, but it's better, let us say I want to run n number of times, then I will say here n. So now I need to say, let us say I want to run only 5 times. Just not run this. Yeah, so this is a true. If I start with x0 value is, let us say minus 2 point let us say minus 2.5, it will find some other root between minus 1 and 2. Okay, right. So this n is in your choice. So this is how you can make use of let me also give you one more one more example. One of the exercise in the last assignment, I had asked that in case you have a circle, inside that circle you want to plot a regular n-gon, and n can vary. I had asked for equilateral triangle, square, up to hexagon, but suppose I want to generate n-gon, right? So how do I do that? So let me just give you, this is quite simple. Okay, so let us see what one can do. I'll just explain this code. This is quite simple. So first, let us generate a circle, unit circle. Okay, and after that, first you want to generate the set of points. How many points do you want? So let us say I want 12 points, or let us say start with n is equal to 6. N is equal to 6, right? So and then the angle that it will, the first point will be making angle with x axis will be 2 pi divided by n, right? Now then generate a set of points. So set of points is, what is the first point? Cos theta times I, sin theta times I, and for I going from 1 to n plus 1. Okay, before that let me just explain one more thing. Many times you want to generate a data, let us say I want to generate 10 numbers. I want to generate 10 random numbers between 0, let us say 1 and 100. So you know that there is a function called rand int, and let us say 1 to 100. This will generate a random integer between 1 and 100. But I want to generate 10 of them. So I have to run this 10 times. That looks foolish because in case I have 1000 times, one can't keep on writing this. So what we will do is, you will say that put it is in square bracket, and how many times you want to generate, that you put it in for loop. So for I in range, how many times you wanted, let us say I want 100 of them or 10 of them. Okay, and close square bracket, this will generate a list of 10 integers. So this is a very convenient way of writing, generating some list of objects or list of numbers using for loop. This is one line you can write this for loop. So that is what I have used here, right? So first point is cos I theta, second coordinate is cos sin I theta, and do this for 0 to n plus 1. So starting theta equal to 0 will give you the point on the x coordinate, right? And after that let us say plot these points, right, with some size, and then the polygon will plot the polygons between those two lines. Okay, so let us see. First we have got this. So if I say now C plus PT It will generate a circle along with these points. Let me make the size slightly smaller. Fine. Let's okay. Right. So this is, and now we want to add polygon to this. So if you add polygon to this, you can use polygon function and ask it to show. Right. Now instead of this is quite simple. So again we are using for loop. And suppose instead of 6 I want let us say 12. Okay, this is what you got. So of 12 I want let us say 20. Okay? So this polygon seems to be very close to the actual circle. In fact, you can use this to approximate value of pi to certain decimal places. Okay, so maybe you can try to create a slider using at the rate interact function that we have discussed in last lecture. You can I think I have, so I'll put this as an exercise. Let me make this as markdown. So this is exercise. What is the exercise? Create interactive plot uh, of this. By this I mean the above one, to explain the approximation of pi with error. Right? How to approximate pi using this the length of the n polygon inside the unit circle, and whatever is the error you should print it. So that you should create a slider by when you change n, it should print what should be the error. It should also show the graph. Okay, so that is quite simple. I'm sure all of you can do it. Okay, this is so this, if you want to generate what are the numbers which are co-prime to 20, this is again we can use one for loop k, generate k for k lying in between 1 to 20, and when which k to take when if GCD of k and 20 is equal to 1. You can see here, right? And this function we already made use in first class itself. Instead of 20, if I make it let us say 100, then it will generate. So here it will be 101. Yeah, so all these integers which are co-prime to 100. Okay, so this is another very convenient example. Okay, so this is how we can make use of for loop. Now let us look at how we can make use of while loop. Okay, so general syntax for while loop is while small letter, and again you have to write condition. It could be one condition or it could be several conditions. It could be several conditions and one conditions or several conditions, and then again colon, and then followed by the list of expressions or statements that you want to execute. This is a general syntax. So let us say, for example, let us take some simple example. So I think this we already did in the first assignment. There was one question that in case you invest let us say 50,000 rupees using in compound interest with interest rate of 5, and interest is computed after every 4 months, after every I think 4 months, then how many years it will take to double the investment. Okay, so let us look at how we can write this command, this using for loop, using while loop. Okay, so what is that we have? We have P is the principal, which is 50,000, and then interest rate is 5%. N is number of times interest is calculated. So in this case, 4 times it is calculated, because after every 4 months you are computing the number of year you don't want, right? So and let us say so what is the while loop? So while a, that is the amount, is less than equal to 2p, less than 2p, that is twice of the principal, then you compute the a, which is equal to p into 1 plus r divided by r times 100 to the power n times t. That's the formula. And then you increment t by 1, t by 1, and then at the end you should print what is the t it has taken. So you see that last t is t plus 1, so it should happen the previous t, and then t is not defined, so I have to define t as a variable. Okay, you can see here I have not declared t as a variable, so let us say var. Yeah, so we have to start with t equal to something, right? So let us start with t equal to 1 to begin with. Yeah, so it has taken 14 years and the investment is 1,108 something. In the previous year it will be, so it has taken 14, it takes 14 years to double the investment. So we are making use of while loop. So you see that this in case we have the knowledge of this while loop, for loop, etc., the things becomes quite easy. Now let us say, take the same example of Newton-Raphson method, and see here we ran for number of iterates. In case we want to find the root which is correct up to certain number of decimal places, or it is accurate to so much, it gives so much accuracy, etc., then in that case we can make use of while loop. So for loop we can make use of while loop. So let us see how we can do. Right. Yeah, so again let us take the same function, fx is equal to x cube minus 3x plus 1. X naught, again we'll start with, let us say, 2.5, and then the tolerance limit is, let us say, 10 to the power minus 5. This is 10e minus 5, means 10 to the power minus 5. And let us say the error is, to begin with, is 1, and while this error is more than tolerance limit, you keep on computing x1, then what is the error? Error is the absolute value, absolute value of the difference of x1 minus x0, and then re-initialize x1 as x0, and then try to, at the end you print what is the root. So you can see here, this we have made use of tolerance error, and this is correct up to 5 decimal places, right? In case you want to make it let us say more decimal places, 8, then the roots will be more accurate. Okay, and of course you can make this as a user defined function. So I'll put this as an exercise, one of the assignment. You can use while loop to find roots of any function, and of course when you have look at some program, in that they may use while as well as for loop, because uh, in some cases if the tolerance limit is very very small, it will take a lot of iterates to converge. But in that case you don't want, you want to stop this after a certain number of iterates, whatever the value you get. So one generally combines both for loop and while loop together uh, in many cases. Okay, so you can look at that. I'll just give you one more example. This is just some of you or many of you must have studied solving system of linear equations using Gauss-Seidel method, Gauss-Jacobi method, Gauss-Seidel method. So this is small program to find the solution of system of linear equations using iterative scheme or numerical method called Gauss-Seidel method. So here you can see we are making use of while loop as well as for loop, both are done together, and in fact this is a nested for loop. So there is a for loop inside a for loop, right? So so all sorts of things. In this case you can see here we have made use of if, we have made use of for twice, we have made use of while. So all these things are there. Of course this notebook will be shared with you, so this command will be available. So in case you have not studied this Gauss-Seidel method, then you can look at the internet. You can ask Google, and then try to first understand what is the algorithm to find a solution of a system of linear equations using Gauss-Seidel method, and then try to understand how this code is going to work. So let me just run this and say make use of one example. So this is a three equations in three variables. So this is Ax equal to b. A is this matrix. So let me print what is. Let me ask it to show. So A. I'll also ask it to show b, the vector b, and this is the starting value. So I'll ask it to show x naught. This is starting value, and then apply this Gauss-Seidel method and ask it to print the roots. So this is what we are taking. This is the matrix A. So this times x comma y, x plus y, x y z, multiply this by x y z. So we are looking at the equation as 9.1x plus 3y plus 5z is equal to 4. Then 3x plus 8y plus 4z uh, is equal to 5, and then 5x plus 43y plus 66z is equal to this, and then we are solving. Starting guess value is 0.0. You can start with, let us say, 1, and then 2, maybe 3 here, 1 2 3, and then you can see here the solution is almost the same. uh, there is a result which says that it will converge under certain condition. So in case you have done this, you will be aware. Otherwise, you can just look at maybe Wikipedia how this Gauss-Jacobi method works. Okay. So many times when you are running a loop, you need to break in between, right? You don't know how many iterations it is going to require, so you need to break in between in case certain condition is satisfied. Or sometimes you want to skip some iterations. In that case, one can make use of what is called break and continue state. Break and continue. Break will break the loop and come out of that. Continue will skip that particular state. So let me just give you an example of that. Mm. Break and continue example. So let us say uh, you want to find out, let us say what you want to do, you want to find, let us say, sum of integers between, let us say, sum of natural numbers, and in case the sum exceeds 10,000, then you break, and then, right, so you add 1 plus 2, 1 plus 3, and so on. The moment it exceeds 10,000, then you stop and say how many numbers it is required. So we are saying that add first n natural numbers so that it just exceeds 10,000. That's the question. Now how many natural numbers it will require, and then try to print what is the sum. That is, so here we are starting with n is equal to 10,000. So it is not definitely not going to require more than 10,000 iterates, right? Start with s equal to 0, and for k in range capital N, right, do s is equal to s plus k, and then in case the s is bigger than 10,000, then you break, right? So it is the moment the sum becomes more than 10,000, it will break, and let us say how many iteration it is going to require. So it is 141. So you can check here, 141 into 142 divided by 2, this should be 10,011. So 141, sum of first 141 natural numbers exceeds 10,000, right? So this is using break. But sometimes you want to, let us say, skip some step. So let us take an example. Suppose I ask a question, find sum of all positive integers from 1 to 100, which is not divisible by um, which is not divisible by either 2 or 3 or 5. Okay, not divisible by 2 or 3 or 5, right? So how do we do that? So we can say that in case it is divisible by any of these things, then you skip that step, otherwise you add. right? So that could be, that is an idea. So let me see how one can do this. Okay, so let me see how you can do it. It's quite simple. I'll just explain what is this code. Yeah. So you start between 1 to, let us say, I said 1 to 100. Again, we want to sum, then we have to initialize s equal to 0 for I going from 1 to n plus 1. Right? And if s I percentage 2 is equal to 0, that means remainder when 2 I is divided by 2 is 0, or divided by 3 is 0, or divided by 5 is 0, that means it is divisible by 2 or 3 or 5, then you skip that. And otherwise you so let me say, I'll remove this, this is not required. Then you add, otherwise you add s equal to s plus I, right? So let us run this, and then let us say print what is s. So this is 1268. This is sum of all integers between 1 and 100 which are not divisible by 2 or 3 or 6. So if you just want to check whether it is correct or not, let us say I want to give only 20, and then this is fine. I will also say print, I'll also say print print s, not s, print I. It will print what are the integers. So you can see here the integers between 1 and 20 which are not divisible by 2 or 3 or 5 is 1, 7, 11, 13, 17, 19, right? So it will, s is going to be the sum of all these, right? So this is how we can make use of continue or for inside or break inside. This is very important in case you are writing program, right? So yeah, there are other things that you may try to use. For example, one thing is, in case you can use what is called try function, and then there is also called except. So this particular code is just printing finding 1 by x, and in case x is equal to 0, of course we know that 1 by 0 doesn't make sense. So in that case, whenever that is 0 division encounters, then you print infinity, right? Sometimes you can also make use of, there are other things like assert. When you want to assert that some variable is, let us say, positive or bigger than something, you can make use of assert. You can make use of assume. There is also something called pass. There are several other things, etc. But what actually I try to do in this worksheet is some very basic programming skills that you require in order to make use of Sage in a much better way, rather than just making use of this Sage as a black box, right? Just do give some command, gives you output. You don't want that. In case you want to solve some problem in a particular fashion and it is not ready already inbuilt in Sage, then these knowledge of making use of if, for loop, while loop, defining functions, etc., will be very useful. And I think you don't require just a lot of programming knowledge skills in Python. With these things, I think I'm sure you will be very comfortable using Sage for most of your work. That is what I wanted to convey in this lecture. So I will of course I'll send you assignment separately, which will be uploaded in the app. So once again, I request all of you to register in that app and also using Telegram, so that you will get all the assignments, etc. Of course, let me once again reiterate that you don't have to submit the assignment. These assignments, you can do it for your satisfaction, just to check whether you have learned these things properly. And one more thing, many people are asking whether we will get some certificate after these lectures, etc. So I have made it clear in the beginning also that I'm not planning to give any certificate. See, the best certificate is your knowledge, your confidence. That is the best certificate. A certificate, after all, is just a piece of paper. But if you have a certificate but you are not confident in using Sage, it's of no use, right? So I am not after any certificate. I generally discourage people to attend some program only for the certificate. So I hope all of you learn this properly. That itself will be a good certificate to you. And in case you want to have some certificate, you just send me, okay, a list of things that I know this, I know this, I know this, etc. You create a certificate for yourself. I will sign and send it to you. Okay. So thank you very much for your attention, and you will get the assignments and the solution of the previous assignment in coming next 1 or 2 days. So thank you very much.